Hello and welcome to 5-Minute Math. Today we are looking at input-output tables. This is Readiness Practice 4.5b, the Proficient version. If you're interested in exploring the intermediate or advanced versions of 4.5b, or if we're looking for Readiness Practice resources aligned with any other standard, you can find those by using the link in the video description. So our first problem, we have a baker making cookies, and for every batch of dough, she has 3 cups of flour that she needs to use. We are going to create an input-output table. So let's do that. So we're going to make it pretty simple. I'm just going to make a little T-chart here. And we want our input to be number of batches. So I'm just going to put batches. And typically, when we make our input-output table, if we make it like this to where the columns are left and right, we have our input on the left and our output on the right, though it doesn't always have to be like that. And then batches, and then flour. And all we know is that for every batch of dough, so I'm just going to, I'm just going to replace that with the number 1. We know that there are 3 cups of flour. And that's the only clue we have. So if I were to double that, if I had 2 batches, I could have 6 cups of flour because each batch is going to have 3 cups. So if I had 3 batches, then I would have 3, 6, 9. And then let's say, what if I had, just going to skip up to 10 batches. Well, each of those 10 batches is going to have 3 cups of flour. So I can skip count by 3 10 times. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. All right, so we can go on, and your input-output table might be slightly different than mine. But we need to write a rule using a numerical expression and then describe the pattern we see. So what is our rule? All right, so let's write that over here. What are we doing to get from our input batches to our output flour? Well, we multiply by 3. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and so on. And we get that because for every batch we have 3 cups of flour, so that gives us our times 3 right there. And then we can describe the pattern we see. We can also use words. So we can say multiply the batches, and then I'm going to put in parentheses, that's our input, by 3 to get and these are cups of flour, and that is our output. All right, so we have our sentence, we have our input-output table with a sample number, and we might say that tables and sentences may vary. So yours might be slightly different than mine, but we all will need that same rule of multiply or times by 3. For our next problem, we have an input-output table drawn for us. They give us the rule, the output equals our input minus 19. Now, they kind of give it to us backwards here. We could just take this output and the equal sign, and we can move it over to this other side. And that might help us because what that does is you can always flip which side the equal sign is on. It could be on the front side, it could be on the back side. But now it's in the same order as our table. Input, right? We see this minus 19 is going to equal our output. And so that's going to be our rule. They give it to us in a longer equation of output equals input minus 19, but our rule, if we wanted to boil it down, would just be a minus 19. So what our expression is going to be, we take our input. What is our input? So we just copy down the 45, we copy down the 51, we copy down the 60, and our 63. So that's going to be our expression we put in the middle, our input, and then a minus 19. And then we just subtract. And our output is going to be whatever 45 minus 19 is. Now, if you need to, you can do it vertically. I'm just going to put our answers here. So this is 26. And this is going to be, now here's what we can do. We can know that we could do 51 minus 19 to get the answer, or we can say our input increased by 6 from 45 to 51. So our output, since we're subtracting 19 again, output is going to increased by 6, and that's going to be 32. Our input increased by 9 from 51 to 60, so our output is going to increase by 9, 41. And then our input increased by 3, so our output is going to increase by 3. So I just did that mentally. Once I got that first one done, you could have separated them all as well. So we need to fill in the missing outputs. We did. And we need to explain what the rule does. So we'll say the rule subtracts 19 from the input. And the reason we have to always write it in a sentence is sometimes when we are taking a test, the answer is going to be a real quick, what is the rule? And you might get a minus 19, but sometimes the answer is always going to be in the form of a sentence. And you might need to write a sentence, or you might need to find the correct sentence from 4 choices. And so we need to be able to practice reading the rules in full sentences in addition to expressions like minus 19. Now, we've got a full table. We don't have the expression in the middle. Our third problem just simply asks us to write the rule. All right, so how do we get from 6 to 48? Well, we've got 2 options. We can either multiply or we can add to get larger. So 6 times what makes 48? That's a basic fact. That's going to be times 8. And then 6 plus what makes 48? That's 42. We don't, both of those could possibly work, so we need to take those down to the next one. So 9 times 8, does that make 72? Yes, it does. Plus 42 is only going to get us 51, so that's not going to work. So I don't think the 42 is going to work. Let's check our times 8. 96, yes, times 8. 15 times 8 is 120, yes. So our rule is going to be pretty simple. We're just going to write that multiply by 8. But for that very first row, it could be a multiplication or an addition in order to get bigger. So you have to apply it to the second row and then the rest of them to see which of those two is going to work for all of them. So if you were interested in exploring the 4.5B Readiness Practice resources for intermediate or advanced, or the Readiness Practice resources aligned with any other standard, you can find those by using the link in the video description.